When we're multiplying polynomial expressions, it is really nice to be able to think of things as shape and area. So I have this expression here. I have 3x times plus 2y times 3y times 1x. It's going to give me this area in here, and I can split this up into different parts here. So let's first of all write the expression for the total area. It's going to be 3x plus 2y, my length, times my width. And I can distribute this out, and I end up with 9xy plus 6y squared plus 3x squared plus 2xy. Okay, so those are the four parts. I can combine by like terms. And I can rewrite this as, maybe I'll just write this as 3x squared plus 11xy plus 6y squared. So I can see it in four different parts here. I can just combine some of those like terms. When I look at these pieces, all these areas must add up to the same area. So if I were to add up A and B, I should end up with this expression here, because this is my total area. And I can decompose this in its area parts as well. So for example, if I multiply to get the area A, I end up with 2y times 3y, which is 6y squared. If I want to get the area of B, what I can do is I can take the area, the whole area, and take away this area A. If I were to do that, I can do 3x squared, the total area, plus 6y squared, and I can take away that area of 6y squared, and that gives me the net area of 3x squared plus 11xy. So that is the area of B, the expression for area of B. Now notice that I can break this down into pieces and get that same area. 3x times 3y plus x is going to give me 9xy plus 3x squared in here. This little area in here is 2y by x, so 2xy. And notice that these areas add up to the same as that. And no matter how I do it, these areas have to all match up. What about squaring something? When I square a binomial, I get a square. So when we talk about squares, perfect squares, we're talking about a square shape, and there is this square symmetry. So it says, is there any symmetry? Yes, of course, there's square symmetry involved in here. So when I square out any binomial term, a plus b squared, whether I have a plus b or a minus b, I'm going to end up with a square shape. So a squared plus 2ab plus b squared is a square shape. A squared minus 2ab plus b squared is a square shape. And notice that just the two squares by themselves do not make a square. Okay, so we cannot square when there's pluses and minuses. We have to write it as multiplication to do that. So if I were to show a plus b times a plus b, I would get my a square, I would get my b square, and I have my AB parts here and here. Okay, so then notice that there's my two squares, and again, if I just squared those individually, I wouldn't have the whole picture, because two squares do not make a square, and squaring something like this must give me a square shape. So what does the product of sum and differences look like? Is there any symmetry? Yeah, there is. If I take the product of a sum and a difference, okay, I end up with something like this. Ax, let's start with x. Let's add some amount, let's say plus 2. And if I were to do x minus, okay, I could do x minus. So if we have a square here, so to get a square, well, I would need to, I have to, well, I'm not going to get a square. So let's minus 3. So there's my x squared, and let's say that is x and x. I can add 2 to one side, and maybe I'll do this in color. So I'm going to do plus 2 on one side. That means I'm going to make this side longer by 2. So that's going to be plus 2. And I can take away from the other side. Minus 3 is going to mean I'm going to take away 3. Okay, so I'm going to go like this, and I'm going to minus 3 here. So this length in here is going to represent x minus 3, and the area that I end up with will be this area here. I've lengthened one side, I've shortened the other side, and this is my area. This is my resulting area. And I can see that I have kind of two parts to this area. So this part is going to be x squared minus 3x. So this area is going to be 2x minus 2 times 3 is 6. So there's my two parts of area. And when I distribute this out, I should get the exact same result. So adding to one side, taking away from one side. If I distribute this, I end up with x squared minus 3x plus 2x minus 6. And notice that there's all those terms. I can combine my like terms, and there's my total area. So this area in here, this is the same area that I've highlighted in the rectangle. So when we do a sum and a difference, there is no symmetry, there's no square symmetry involved in here, because if I start with a square, start with the length and width x, and take away from one side and add to the other side, we do not get a square shape, so we get this kind of rectangular symmetry.